All right, here we go on the back side of the notes. Now, I will not lie to you. This is going to be a straight-up application for MyMathLab Day 1. Hopefully you can follow that and understand a lot of the stuff we did on the front page important, but here's going to be how you're going to be successful in MyMathLab Day 1. It's going to go a little bit quicker. Straightforward example. I hope it would make sense to you if we have like bases that would mean U would have to be equal to V. Easily. That's a very straightforward conclusion with like bases. It's the only way it's true. Looking here on my copy, there's something missing. That should be a minus there. Hopefully that's on yours. So what we have here is we have an exponential function shifted right 4 equal to, oh, there's a negative missing here as well. An exponential function with a horizontal reflection. All right, we're going to do all algebraic here. All we're going to focus on is algebraic, this first part. That would mean, based on what we just said, that x minus 4 must be equivalent to negative x. The exponents must be equal to each other, okay? So it doesn't take much work here to see 2x equals 4. Adding x to both sides, we're going to get an x value of 2. Now, what does that mean? Well, I'm not going to even attempt to try to do a good graph with this because I can only get so accurate. So I want you to know what I did is I loaded this up on the Inspire for you to see. So looking here, exponential shifted right 4, like we said, horizontal reflection. So look at this real quick on this graph. Right here in blue is the exponential function shifted right 4, and then I just do that. Sorry, lost myself in my words here. I actually show, I'm getting caught up here on this, the exponential function. That's what I wanted to trace there for you. Okay, and then the red one there is the reflection. If you notice, look at this. How neat is this? Where do they cross? X value of 2. Now, obviously, I could go through and, yeah, why not? It takes 2 seconds. So go through, analyze the graph, look for the intersection. Okay, where's the intersection here and here? The intersection is at, you can see 2, 0.135, but the X value is 2, and that's the point of what we're saying. Okay, so we got an X value of 2, and we showed that graphically as well. All right, but let's stick to algebra here. We want to get the same base, basically, for this to work out. So I can think about this as 2 cubed. Remember, 8 is 2 cubed, and that's raised to 3x plus 1. I think some of this is going to be a recall for you guys. And then this one here, I can think about this as 2 to the negative first power raised to the x minus 2. So very careful there, power of power. What we do is we multiply, so this would go through just the exponents, and we'd have 9x plus 3. And that's going to be equal to negative x plus 2. Again, what am I doing? I'm setting these exponents equal to each other, and power of power, we multiply those. All right, so then I'm going to get 10x equals negative 1. X equals negative 1/10. All right, other scenarios. Look at a few more of these. This one here, like bases here, what's the rule? Well, the rule then is to, oh, I guess I could go through that rule, but again, power is going to be 4x. That's what that's going to be. So we're going to have e to the 4x. I can show my work. I guess I should slow down. These are notes. X squared equals e to the 12th. So what do we got here? Well, we've got 4x plus x squared equals 12. Now, how can I do that? Well, they're all the same bases. And when you have the same bases here, multiplying same bases is add those together. I could show another step, but you'd end up setting these two equal here. So where am I at? I've got x squared plus 4x minus 12 equals 0. And we're going to want to factor. Teach me how to factor. Teach me how to factor. Okay, so here we go. And we've got x, plus 6, and x minus 2 will get you home. So we're getting two answers to this one, x equals negative 6 and x equals 2. All right, moving along here, this one definitely looks a little chaotic. I don't know the best way to show you this one. Maybe 3 times 1 over 9 to the 2x. Maybe that is good. I don't know, I'll just kind of play around and get there eventually here. We're going to try to get to base 3. I think that would be pretty straightforward. So 81, then I would want to rewrite as 3 to the 4th power. 3 cubed is 27 times 3 is 81, so we've got that. Then times 3 to the x power. So you can see just going on this side, I can get that all the way to 3 to the 4 plus x, base 3 here. So how can I get this one to base 3? Well, I can do 3 times, well, I can rewrite this as 1 over 3, and then that can be, 2x right here, like 2x or 4x, So I can write it as 4x. All right, so let me explain that a little bit more. If I look at this one right here, you know, this is 1, whoa, this is 1 over 3 squared, right? Just this part that I circled, right? 3 squared and then raised to the 2x. Well, that's 4x. So that would be, you know, obviously 3 to the 4x power. And then again, if the 1's on top, you can make the entire fraction to the 4x power. Well, then watch where I'm going with this. So 3 times 3 to the negative first power to the 4x equals, again, this side, which is just kind of staying the same. That side was a little quicker to get there. But again, what do we got here? We got a 1, right? We got a 1, so we got 3 to the 1 plus, and then you got to have the negative 4x equals 3 to the 4 plus x. Same bases, add those exponents, and this is really negative 4x. So then we can just basically say 1 plus negative 4x equals 4 plus x. Add 4x to both sides, we'll get 5x, subtract the 4, we're going to get negative 3, we're going to get negative 3/5 for our answer to that one. All right, last but not least, this is a little unique one. Look at this. It's a little different. They give you some information and then they say find that. Well, that's great. How do we do that? Well, we got to think about this differently. If I can think about that with what they gave me, well, here is known, this whole expression is known as 4. So what can I didn't write that the best, but 5 to the negative x power. Well, if I want that to equal this right here, it has to be the same thing. I can raise this to the negative 3x power because, whoops, just negative 3 power, no x there. Okay, because this now says 5 to the positive 3x. Everything is exactly the same here as in this circle. Okay, well, what is 5 to the negative x? Oh, that's 4. So basically, straight up substitution, we get 4 to the negative third, which is 1 over 4 to the third, which is 1 over 64. All right, now try My Math Lab Day 1 and get it done before you come to class tomorrow. Thanks so much.